Okay, Bismillahirrahmanirrahim. Assalamualaikum and hello guys. Alright, so in this video I will discuss questions from chapter 2.3, techniques of integrations. So please do check your answers if you have any problem with the questions. Okay, so first number 7, the question asks to use this one, cos 3x equal to this, and evaluate the integral. Okay, so as we notice here, we cannot directly integrate cos cube x. So we can use the information given here, which we can see that we have cos cube x over here. We have cos cube x over here. Okay, so what do? We just need to arrange the equation. Okay, so we have cos 3x equal to 4 cos cube x minus 3 cos x. Okay, so we want this one to substitute. So we bring this one to the other side. So we bring negative 3 cos x the left hand side. Okay, and we have 4 over there, so we just need to bring to the other side, become divided. Okay, divided. So cos 3x plus 3 cos x divided by 4. Okay, so now we get what we want, which is this one. Okay, so what do we do next? We just need to substitute this one with this. Okay, so we substitute first. So 0 until pi over 2. So now we substitute this one with this. So cos 3x plus 3 cos x power 4 dx. Okay, so now we can directly integrate. So first of all, I will just bring 1 over 4 to the front because it is a constant. Okay, and then we have 0 pi 2 cos 3x plus 3 cos x dx. Okay, so now notice that we can integrate this one directly and also this one. Okay, so continue. So integrate. So when you already integrate, make sure you use the square bracket. Okay, so integrate cos 3x is positive sine 3x. Don't forget to divide it by 4. Sorry, divide it by 3. And then plus 3 sine x. Okay, so 0 until pi over 2. Okay, now we just need to substitute our upper limit first. Okay, so substitute upper limit, which is pi over 2. So sine 3 pi over 2 divided by 3 plus 3 sine pi over 2. Okay, this is your upper limit. And then you just need to minus. Now you substitute your lower limit, sine 0 over 3 plus 3 sine 0. Okay. Okay, so you can directly use the calculators to find the value here and here, and make sure your calculator must be in radian. Okay, because we use pi for this question, so it must be in radian mode. So calculate, and then you will get your final answer, which is 2 over 3. Okay, this is your final answer. Alright, that's for question number 7. Okay, now let's continue with question number 8. We have 3 questions to answer. So notice that for these 3 questions, you cannot directly integrate, right? Okay, so let's try using the substitution method. Okay, so we're going to use substitution method for this question, which you have to choose and find your right u. Okay, find and choose the right u, and make sure everything has been changed in terms of u. Okay, so for A, okay, we have e2x, we have 4 minus e2x, and we have 2x as the power of index. So which one gonna be your u? The answer is the one below. The denominator gonna be your u. Okay, so this is actually your u. So as I mentioned before in the lecture, make sure you write it, everything that you have changed. Okay, so we have this. Okay, so notice that we haven't changed e to x and dx in terms of u yet. Okay, so what do? We need to differentiate. Okay, this is your u, so you differentiate, and then you need to substitute the dx first. Okay, substitute the dx first. So the dx will be equal to this. So we're gonna substitute, become du over negative 2e to x. Okay, and then notice that we can cancel out e to x over here, e to x divided by e to x, and then we can bring negative 1 over 2 to the front because it is constant. Okay, now everything has changed, become u, so now you can put in your working steps. Okay, so this one will become negative 1 over 2, 1 over u du. Okay, so integrate 1 over u is 1 modulus u plus c. So don't forget, make sure to substitute back your u, which is 4 minus e to x plus c. Okay, so this is your final answer. Okay, moving on to next one. So we have integral of this to the power of 5 and then secant square. Okay, so which one is your u, guys? Okay, the answer is the function inside the bracket. Okay, without the power. Okay, this is your u. Okay, so again, I put it like this. We have u to the power of 5 and then we have secant square x minus 5 dx. Okay, so we still have this to change in terms of u. Okay, so what do? Again, we differentiate. Okay, so we have this as our u and then we differentiate, and then you can substitute your dx, find your dx. So your dx is equal to this. Okay, your dx is equal to this, so we're gonna substitute. Excuse me. So your dx is equal to du divided by 3 secant square x minus 5. Okay, again, notice that we can cancel out the secant square over here because it's the same thing. And then you can bring out the constant. So the constant is 1 over 3. So what's left is u5 du. Okay, now everything has been changed in terms of u. Now you can put your working step. Okay, so I put it somewhere here. So become 1 over 3 integral of u5 du. Okay, so you can directly integrate, become u6 over 6 plus c. So u6 over 18 plus c. And don't forget to substitute back your u, which is 3 tangent x minus 5 plus 1 to the power 6 plus c over 18. Okay, so this is for B. Okay, for last question, for the last part of question 8, okay, we have this function over here, and notice that we have ln over there. Okay, remember we cannot directly integrate ln. Okay, we cannot directly integrate ln, so normally, okay, usually this will be your u. Okay, for function that involve ln, normally this will be your u. So the function inside will be your u. Okay, so again, now we have 2u squared over 5x dx. Okay, so next step is we're gonna differentiate. So this is the step. We have u, differentiate become ln x. So I need to substitute dx, okay, to change everything into u. So our dx is equal to x du. So we have 2u squared 5x and dx become x du. Okay, again we can cancel out x over here and then bring out the constant, which is 2 over 5. So what's left inside is u2 du. Okay, so we have no problem to integrate this. So now you can put in your working steps. So we have 2 over 5 u2 du. Okay, directly integrate. So u over 5 u3 over 3 plus c. So u over 15 u cube plus c. So u over 15, your u is ln x. Okay, so this is your final answer. Okay, that's it for question number 8. Okay, now moving on to question 9. Okay, so for this question, obviously you cannot directly integrate. And then if you use the substitution method, there will be no way out. And also, I think it will become more complicated. Okay, so since we cannot use the two methods, we're going to try another method or another technique of integration, which is by part. Okay? Okay, if you still remember, for the by part, we're going to use the formula, which is the formula is u dv equal to uv minus integral of v du. Okay, so this is our questions. So from the question, we're going to identify our u. Okay, we're going to identify our u or choose our u. So how do we do that? We're going to use the law pack. Okay, the law pack. Okay, so let's straight go to the question. So the first one, A, we have x minus 2 multiplied ln x dx. Okay, so we're going to choose our u now. So see if we have ln function. The answer is yes, we do have ln function. So this is our u. Okay, and then the rest of that is, the remaining one is our dv. Okay, our dv. Okay, so what do we do next? For the u, we're going to differentiate it, okay, to get our du. And then for the dv one, for the dv, we're going to integrate both sides, okay, to get our v. Okay, so integrate dv is v, integrate this one, we're going to get this one. So now we have our u, we have our du, and we have our v. What do? We're going to insert into the formula. Okay? Okay, so based on the formula, we have u dv, so we have u dv equal to uv. uv. So we have uv, and then we need to minus with integral of v du. v du. Okay, so we have x squared over 2 minus 2x, and our du is 1 over x dx. Okay, so now we need to leave this one, okay, because we don't need to do anything with this. We just need to integrate this one, so you can expand your function to make it easier for you to integrate. So we're going to expand it. It will become x squared over 2x minus 2x over x dx. Okay, so we can simplify the function. It will become x squared over 2, x over 2. And then this one become 2 only. Okay, now we need to integrate the function. Become x squared over 2 multiply 2. And then minus 2x, and then plus c. Okay, so last step, we just need to multiply or expand the negative one, the negative at the front. So the final answer would be like this. X squared over 4 plus 2x plus c. Okay, so this is your final answer for A. Okay, moving on to B. So for B, we have the square root over there. Okay, so I'll just change into the power. So we have x over 3. This is x plus 2 to the power of 1 over 2. So I'll bring it up, become negative 1 over 2 dx. Okay, so now how do we integrate this using by part? You need to choose your u. Okay, so to choose your u, we need to check whether we have long function. The answer is no, we don't have long function. Next one, we check whether we have polynomial. The answer is yes, we have polynomial. The function which the variable has positive integer as the power. Okay, so this is our polynomial. Okay, this is not polynomial because we have power negative 1 over 2 over there. This is not polynomial, so this will be your u. Okay, so this is your u, and the rest is dv. Okay, this is your u, the rest is your dv. Okay, again, do the same step. Okay, so for u, you're going to differentiate to get your du. And then for the dv part, you have to integrate both sides to get your v. Okay, so now again, we're going to substitute into our formula. So the formula is u dv, which is our question. Equal to u v minus v du. So u v. Okay, so u v minus integral of v du. Du is 1 over 3 dx. Okay, so I'll bring 2 to the front, so it will become 2x over 3. And then for this one, I'll bring the constant outside. So we have 2 over 3. And then what's left is x plus 2, 1 over 2 dx. Okay, so this is still the same. And then for this one, we can directly integrate using the formula from basic integration formula. So the power will become plus 1. So 1 over 2 plus 1 is 3 over 2. And then divide with 3 over 2. And also differentiate inside, which is 1. Okay, and then last one plus c. Okay, so don't leave your answer like this because you have fraction as your denominator. Okay, so for the final step, it will become 4 over 9 x plus 2, 3 over 2 plus c. Okay, so this is your final answer for question B. Okay, Okay, for the last part for question 9, so this is also simple because we can easily identify our u. Okay, so again using logpad to choose our u. So do we have long function? No. Do we have polynomial function? The answer is yes. So which one is your polynomial function? It is the 2x. Okay, and the rest is your dv. So this is your u, the rest is your dv. Okay, again, the same step. Differentiate your u to get du, integrate your dv to get your v. Okay, and then substitute into the formula, and then integrate this one, and you get your final answer. Okay. Okay, so now we are at the last part of this video. We're going to discuss question number 10, which involves the last technique for integration, which is the partial fraction. Okay? Alright, so for this type of question, you have to make sure that your numerator and denominator has been factorized into linears completely. Okay, you have to check both numerator and also denominator. Okay, so for this case, notice that for the numerator, you can factorize, become x plus 1, and then the x squared is still x squared. But for this, you can factorize, become x plus 1, x minus 1. Oh, sorry. Okay, so why is it important for you to make sure that everything has been factorized completely? Because we can make sure our function, we can make our function become easier or more simpler. Okay, why? Notice that we can cancel out the x plus 1 over there. Okay, so what's left is only x plus 1 divided by x squared, x minus 1. Okay, it will become simpler version of the fraction before. Okay, so now for this type of function, we're gonna need to decompose because we cannot directly integrate this one, so we're gonna decompose. Okay, notice that we have repeated linear factors over here, and we have another linear factors. Okay, so it will become a over x plus b over x squared plus c over x minus 1. Okay, so next we're gonna equate the denominator, make sure everything has the same denominator. Okay, so for a, we're gonna multiply with x and x minus 1. For b, we need to multiply with x minus 1. And for c, we're going to need to multiply with x squared. Okay. So now all of them will have the same denominator. So what do we do next? We can compare the numerator. We can compare them to find the a, b, and c. Okay, so I write it again over here. So we have x plus 1 equal to a x minus 1 plus b x minus 1 plus c x squared. Okay, so we can use trick over here to find the a, b, and c. For example, we can let x equal to 1. Okay, why? Because if we let x equal to 1, this one will become 0. This one will also become 0. So what's left is this one and this one. So we can directly get the c. Okay, so for when x equal to 1, the left hand side become 2, 1 plus 1, and then 0 plus c 1 squared. So we get our c. Okay, and then we can also find our b by letting this one become 0 and 0. How? So let x equal to 0. So when let x equal to 0, this one will become 0, this one will also become 0, so you get your b. Okay, you get your b. Okay, so we have 1, and then we have 0 plus negative b plus 0, so b is equal to negative 1. Okay, and then since you have value of c, and also you have value of b, you can substitute any value of x. Okay, for example, we can substitute x equal to 2 to the equation, so you're gonna get your a become negative 2. Okay, that's how you get a, b, and c. Okay, so now when you already get your a, b, and c, you need to substitute back into this. Okay, so it will become like this. Okay, so notice that when you already substitute into this, you can integrate this, and this. So meaning your steps are correct, and the partial fraction works for you to integrate. Okay, so you can integrate this become ln, you can integrate this one become 1 over x, and you can integrate this one become ln. Okay, so notice here that I remind you to make sure to put modulus over here. Okay, to put modulus for your ln. Okay, so that's your final answer. Okay, for the last question for B, it's the same step. Okay, it's the same step. So for this one, you cannot factorize this one. Okay, so just leave it like that. Also for the denominator, we have one linear factors, and also we have quadratic that cannot be factorized. Okay, the quadratic cannot be factorized. So that's why we're going to decompose the function, become a divided by the first linear factor, x minus 3, and then for the quadratic that cannot be factorized, the numerator must be linear, which is bx plus c. Okay, so the same step as before, you need to equate the numerator, become like this. Okay, and then you compare the numerator. Okay, you compare the numerator to find your value of a, b, and c. Okay, so you already get the value of a, b, and c. You substitute back into your equation, your partial fractions. Okay, become this. So now we will integrate this one. Okay, so notice that we can integrate this one directly. Constant of the linear will become ln. Okay, but not for this one. Okay, we cannot directly integrate this one. Okay, so what do? We're going to separate the integration. We're going to separate it. Okay, first one is this, and then we have this one. Okay, so we have no problem with this. We can directly integrate, become ln modulus x minus 3. Okay, but for the yellow one, we need to try another method to integrate. Okay, if we cannot directly integrate, which is you can use the substitution method. Okay, so but the question is, what is your u? Okay, what is your u? So you have x, you have x squared plus 2. So your u is actually the one below. That is your u. Okay, so we have x over u dx. Okay, so I write it at the top. We have u equal to x squared plus 2. So du dx is 2x. So you have du become 2x dx. Okay, so notice that we have x dx over here, but the 2 need to bring to the other side. Become du over 2 is your x dx. Okay, so now you can substitute your x dx. Become du over 2, and we still have 1 over u at the front. Okay, so you can bring out the constant 1 over 2, and then we have 1 over u du. Okay, so when everything has been changed in terms of u, you can put back into your working step. So I put it here. So we have 1 over 2, 1 over 2, 1 over u du. Okay, so integrate constant over linear is ln modulus u plus c. And for the last step, make sure you substitute back your u, which is x squared plus 2. And don't forget your plus c. Okay, so this is your final answer. Okay, that's it. Okay, so that's it for today's video. So I hope you really understand, and if you do have questions, don't hesitate to ask me. Okay, so bye, see you guys.